Hi, so for today we're going to talk about substitution suggested by the equation of the differential equation. So basically, this topic is falls under the substitution method of solving differential equations, first order differential equations. So basically, when we are trying to solve a problem or a differential equation that is suggested by the equation, we have to find for the common terms. Okay, common uh, variables and terms in our equation. So for this example, we have x plus 2y and x plus 2y for both the dx and both the dy. So what can we do is to let a variable substitute by the x plus 2y and solve the given differential equation. And by doing that, we will be coming up with a differential equation that is much easier to solve. So for this problem, for problem number 1, we have the quantity of x plus 2y minus 1 plus 3 quantity x plus 2y of dy equals 0. So as I've said, we can let any variable, okay, let's say let v equals, we have x plus 2y because both x plus 2y is common both in the dx and in the dy. Okay, so what are we going to do is we're going to isolate x here. Okay, so we have x equals v minus 2y here. And then we are going to differentiate with both sides. Okay, so we have dx and we have dv minus 2 dy. Okay, so that upon doing this, we can easily what substitute the variable v. Okay, and we are going to have a v and dy at the end of the substitution. So we have x plus 2y as our v. So this can be rewritten as we have v. Okay, this one, x plus 2y, and then minus 1. And of course, we have to substitute this dx so that we get this in terms of x. And then what we did is we have differentiated it both sides so that we can substitute dx here. So our dx will now become what? This one. This one. So we have a dv minus 2 dy plus we have 3 x plus 2y again equals v, and our dy is as is dy. Okay, so now we have in terms of v dv and in terms of y dy. So we can now what simplify this. So we know that this is a FOIL method, so we have v dv first, and then we have the outer v and negative 2 dy, so we have negative 2v dy, and we have the inner. Okay, negative 1 times dv, that's negative dv. And finally, the last negative 1 times negative 2 dy, that's positive 2 dy plus 3v dy equals 0. So if we are going to simplify terms, so we have v dv minus dv, and we have what? We have negative 2v dy plus 2 dy plus 3v dy equals 0. So we have v dv minus dv is actually what? Okay? We cannot simplify this, but rather we can factor out what? dv. So we have v minus 1 and then we have dv here. So we can simplify negative 2v dy and 3v dy. So negative 2v dy plus 3v dy, that's positive v dy, and then we have plus 2 dy here equals 0. And so on, we can actually factor out dy here. So we have v plus 2 dy here. So this resulted into a variable separable dE. Okay? So this is a variable separable. So what are we going to do is to separate, okay? Going to divide both sides by v plus 2. Okay? So we have v minus 1 all over v plus 2 here. And then we have dv plus only dy here. Okay? So this is a variable separable. So if you notice, if we integrate this directly, we will be having a hard time integrating this. So we can rewrite v minus 1, v plus 2 as. So we will be rewriting v minus 1 all over v plus 2. It's very hard to integrate, actually. Okay, you cannot use substitution or partial fractions or whatsoever. You cannot use that. So you will be rewriting, the best way is to rewrite the v minus 1 all over v plus 2 as 1 minus 3 all over v plus 2. So this one is equal to this, equals this. Okay? So that if we evaluate this, v plus 2 times 1 is v plus 2 minus 3. So v plus 2 minus 3 would be v minus 1. So it's the same. Then copy the same denominator. So if we substitute that, so we'll be having 1 minus 3 all over v plus 2. We have dv plus dy equals 0. So integrate both sides, okay, of the equation. So as well as the plus dy here. Integrate that. So we have integral of dv minus 3 integral of dv all over v plus 2. I separated the integrals and distributed the dv. Plus we have dy equals integral of this 0. Okay? So we know that this would be v minus 3. This would be ln. Okay? So this term would be ln, dv all over v plus 2. So that would be ln of the absolute value of v plus 2, okay, plus y equals, or this we can actually write c here, okay, and then equals 0. Okay? So it doesn't matter where you write the c, but I would write here the c, okay, after the integral of y. Okay, so this is our answer. But take note that we have not, we have still the variable v here. The original variable is x plus 2y. So we have to back substitute the value of v, that is x plus 2y. Okay, so we have x plus 2y here. Okay, then minus 3 ln of the x plus 2y, that's the v, plus 2. Okay? And then we have plus y here, then plus c here equals 0. So we can further simplify this because we have plus 2y and then we have plus y. Okay? So we have x plus 3y minus 3 ln of the absolute value x plus 2y plus 2 plus c equals 0. So this can be our final answer. Okay? Or we can to avoid negative, we can transpose this negative 3ln on the other side. So that's still the same. Okay? So number 2, so we have 1 plus 3x sine of y, and then we have dx minus x squared cosine of y dy equals 0. So this is also an example of a substitution suggested by the equation. Why? Because we have the sine of y here, and if we get the derivative of this sine of y with respect to that substituted variable, we can get cosine of y. So let's try that if we let w equals sine of y, then getting the derivative of both sides, so we have dw and then we have cosine of y and then we have dy, of which cosine of y dy is here, and this is the sine of y. So we will be substituting these variables, okay, to make our equation more easier to solve. Okay, so now we have 1 plus we have 3xw, okay, and then copy the dx, and then we have minus x squared cosine y would be, cosine y dy would be dw equals 0. Okay, so if we distribute dx, we have dx plus 3xw dx minus x squared dw equals 0. So now, if I divide this by 1 all over x squared, So what will happen? We have dx all over x squared plus we have 3xw all over x squared dx minus dw equals 0. So we know that this would cancel. So we have dx all over x squared plus 3 omega or 3w all over x dx minus dw equals 0. Okay? So if I'm going to rearrange this equation, we will be arriving at a linear differential equation. Okay? So if I'm going to rearrange this, we have negative dw plus we have 3w all over x dx equals, we have uh, negative dx all over x squared. Okay? So what will happen here is that I can divide still both sides by dx. Okay, so that I have a dw dx here. So we have negative dw over dx here. And then we have plus, okay, 3w all over x. Dx now here in the term here, the second term will be cancelled. So we have now equals negative 1 all over x squared. Okay? If I'm going to multiply it by negative 1, so that this becomes positive, dw all over dx. Okay? And then we have minus 3w all over x equals 1 all over x squared. And furthermore, we can rewrite this so that we can really see if this is linear or not. Okay? 3 all over x multiplied by w all over 1 all over x squared. So this is an equation linear in w. Okay? So this would be our p of x and this would be our q of x. So now, if we get the integrating factor, okay, e raised to p of x dx, okay, and then this is our p of x dx. Our p of x dx is 3 all over x. So that is our p of x. So getting the integrating factor, we have e raised to 3 all over x dx, and that is e raised to 3 ln of x. And then we know that this could be rewritten as, this 3 could be rewritten as the exponent of whatever is the inside function of the ln. So in that case, that's x cubed. So e raised to ln would cancel. So we have an integrating factor of x cubed. Okay? And we know that upon solving the linear, okay, the shortcut is actually, the formula is the dependent variable on the right side, on the left side of the equation, multiplied by what? Multiplied by the integrating factor. Oops, I have a mistake here. I should include the sign, negative 3 all over x. So this becomes negative 3, negative 3. I have to include this, okay? So that becomes negative 3 all over x. So I have an integrating factor that is x raised to negative 3. Again, I've just overlooked the negative here. So this would be negative 3, okay? So this should be negative 3 because of this negative here, okay? I should include the sign in the integration or determination of the integrating factor. So we have w, the dependent variable, multiplied by the integrating factor. And that is equal to what? That's equal, oops, I should erase. Okay, so okay, that's equal to what? The integral of q of x multiplied by the integrating factor. Okay? So the right side of the equation. So we have wx raised to negative 3. And then we have integral. In this case, this is our q of x. Remember, in the study of our linear. So we have 1 all over x squared multiplied by x raised to 3. Okay? So how do we do that? How do we simplify? So we know that this should be what? X raised to negative 2 multiplied by x raised to negative 3. So their exponent will add minus 2 plus negative 3. Negative 2 plus negative 3. So that would result to x raised to negative 5. Okay? So let's continue here. So we have wx raised to negative 3, and that would be integral of x raised to negative 5. And we know the integral of that. That would be x raised to negative 4, okay, all over negative 4 plus c. And rewriting this equation, so we have wx raised to negative 3, and then we have negative 1 all over 4x raised to 4 to get this a positive sign, the exponent, okay? So we get the reciprocal. And then, of course, what are we going to do? We can multiply this whole equation by what? 4x raised to 4 to cancel the denominator. So we have 4x raised to 4 multiplied by x raised to negative 3 multiplied by w, and then we have negative 1 plus we have cx raised to 4. 4 times c is still c, so we need not to include the 4c. So it's still plus cx raised to 4, but we have to include the variable. Okay? And we can simplify this. 4 plus negative 3 or 4 minus 3 would be 4x. Okay? Still an exponent that is equal to 1. Okay? So we have 4xw, and then we have negative 1 plus cx raised to 4. Okay? Or we can rewrite this 4xw, cx raised to 4 minus 1. We have not yet arrived to the correct answer, but rather, because we used substitution a while ago, we should what? Back substitute it with the original variable. Okay? But w, again, equals sine of y. Okay? That's the substitution we did a while ago here. Okay? So we have to back substitute it. So what will happen? We have 4x. W is sine y. So it equals, we have cx raised to 4 minus 1. And this should be our answer for this problem. Okay? So I hope you learned from this video about the substitution suggested by the differential equations or by the equations, a part of the technique of solving first order linear differential or first order differential equations. So if you are new to my channel, please subscribe to my channel, and please look up to the differential equations playlist to learn more about the differential equations. Thank you so much, and see you again on the next video. This is Engineer Abat. God bless us.